So, hi everyone. Um, in this recording, we are going to see the complete execution of the uh, capstone project that I did, which is like building a complete machine learning pipeline on SageMaker. It consists of download processing the data set, downloading it into the SageMaker, then training it, then performing evaluation on the trained model, checking it for accuracy, and then obviously like manually trigger if the accuracy is desirable, then register the model. And after that, we can go ahead, place that model, and then deploy it into at a serverless endpoint. And for this demonstration, we are going to be using Kaggle Intel Image Classification dataset. And also this includes for annotations, we are using Label Studio, which supports data to be uploaded at an S3 and with the annotations. And we can do assisted machine learning annotation also with it. Um, so we can again, like by training, we can add additional data, use train the model, then add additional data by training it, and again train it back with the complete data set to have better results. And with the ML supported backend, which is supported in ML Studio, we'll be able to performing our annotations much faster. Obviously, this is for classification. Same things can be done for object detection, segmentation, basically whatever is our task, supported by Label Studio. So here are the GitHub repos. So um, it is basically divided into four repositories, which is Intel training baseline. This is the first step. So in this first step, we are finding the hyperparameters which are best for our for the model on this data set. For hyperparameter optimization, we are using Optuna, and we are also I am also using here um, Optuna with Hydra, complete Hydra package. So basically, Hydra is a command line tool which makes our testing much faster, and support for everything. We can have here hyperparameter search, everything. It makes it so easier, simpler to maintain maybe different versions of models. We can just like here, if we go in models, so we can have different YML file for each model, and inside our trained.yml, here we can define basically which model we want to use. So maybe we can have different kinds of model, so this makes it much more faster. So for different configuration for hyperparameter tuning, again, Hydra, it gives us Optima integrated hyperparameter tuning also. So the different parameters that that is taken, they are first thing is the model, then the basically base the backbone that is there. So there are different models. They are trained on ImageNet. So I have selected EfficientNet, ResNet, and MobileNet V2, and no doubt EfficientNet is much more superior than, so it was the winner here. Then we have different optimizers. We have learning rate, and then we have weight decay and batch size, because learning rate and batch size, they have connection. So batch size is also an hyperparameter for us. Uh, Again, for starting, like that, for finding the starting point of the learning rate, in that scenario, I have used LR Finder, which is an integrated tool with PyTorch Lightning. Again, that PyTorch Lightning is the basic tool we are using. So you can see these are all the hyperparameters, and this is the graph. So this is the basically suggested hyperparameter in this case. So here is for efficient net also, this. So I have taken a near value for these two, these value with some delta, and I have selected this range with this. Uh, s- and the best parameter which came out, they were, so we were able to achieve 92% of accuracy with loss of 0.3 with the 12 epochs. And here is the confusion matrix, precision F1 score, and everything. So below you will be able to see the confusion matrix image also. And here are all the best parameters, the learning rate, weight decay, batch size, and the best value was 93% percent accuracy. And here are the TensorBoard logs, which can be opened by clicking on this link, by clicking on the hyperlink. So here we have logs for basically different experiments. So if we go in the training section, you'll see all the different experiments with different accuracies here. Same thing for the validation. Now, if we go with in the hyperparameter, so this is the complete hyperparameter graph here. So this results in the best model. So you can see this here. Yeah. So moving ahead, now we have finding the base parameters, basically the parameters which now we can train our model fully on the basis of these parameters only. First, we only during the hyperparameter search, we only trained it for 3 epochs. So now we are going to train it fully for 12 epochs. So here is the basically the SageMaker code which we are going to integrate here. Right? So these are the results for the SageMaker. So after 12 epochs, this was the accuracy, and this pipeline basically took completely 3 hours to run. Now, if we go to, we can also see the logs in the CloudWatch. Just I'll go to logs. I'll go to scroll down. Here is the confusion matrix and everything, accurate evaluation matrices, which are also copied pasted here. So format visualization. These were the training logs. So we were able to achieve 93% of validation accuracy, 94% of training accuracy. So pretty good. Yeah. With efficient and model. And now we can go for model evaluation accuracy. Sorry, model evaluation logs. This we can open this, and so here are all the matrices accuracy. Yeah, everything is here. So this thing, yeah. And this is the tensor board for the SageMaker. So just let me change this color. So now these lines are better visible. Yeah, train. This is the tensor board for the SageMaker pipeline that we initiated. So here is our loss and everything. You can see this is the training accuracy, and this is our confusion matrix, which is logged in TensorFlow board as well. Uh, so this is it. Now, next part is once we have trained the model. If now we will go here under model registry, we can see this. These two are pending model. If I can open any one of these model, um, now this is since manually approved, it showed me this is the accuracy value and this is the standard deviation. There are different reports. Now, if I go for version 3, so here I have this model which is slightly higher accuracy. So I can just go ahead and approve this model instead of that. Approved, update status. Yeah, now this is approved. We, I think, don't need that model. Yeah, so again, like you can go here. This is the standard deviation, which is also low. Good thing, right? Under settings, we can see different parameters and everything, which was used for by the SageMaker pipeline. Here we can see the basically S3 location. So now from here, we can take a model from this location and we can deploy it with the SageMaker, which is basically the next step. So if we open this, now this is basically the front end and the SageMaker pipeline. Yeah. So here we have scripted model, everything. So we can basically put the model here at this particular location. I mistakenly posted to GitHub also. Yeah. And here we can put the ECR image, and now we can deploy it here. After building the image, pushing it to ECR, we can do deployment here. And this is basically the front end, which is also running. So I will just quickly open front end also here. So we can choose file here, all files. Let us open this image, run, and we have this prediction. Cool. Mountain, and yeah, we have 99% mountain. This is good. Okay, so now one more thing is that if you open this, we see the inference code here. So we also have drift detection for each and every prediction which is coming here, which is again which will be logged in the CloudWatch, since we are printing everything. So this is also here. Now the last part is, now once we have trained the have a trained model, we will be using this label studio for our ML assisted labeling. So now if you see this, we have here, I already labeled some images. There are 20 images already labeled. So now if I open this image, now you see this processing, this is uh, labeling going on. So if you see, though this predictions to be come out glacier with 99% of accuracy, I just need to reopen this to see this update. Uh, yeah, so now I can basically correct this prediction if I find it wrong. Now, if you see again, this is mountain. Now, if I will open this again, now see this forest, another prediction which went through this, another prediction, this came out to be building. So now what can I do to where now if I will open this again, I can see this labeling. So what can I do to when I will click on submit, the data these data is taken from S3, and again the annotations are again uploaded to S3 also. So if we open this, we can again see this was forest. Yeah, this is correct. So our model is already pretty good trained. So now if you will open, this is the basically S3 location of the data set. Here is the zip file of the data set, and here are all the prediction images which are coming from here they are coming, and here our annotations are getting updated. So basically these are the task number 20, 21, 23. These are the task number by which our annotation got updated. This is JSON format. So if we currently download, we can download this, download, and we can open this file in Notepad or VS Code also. So I'll just go open with VS Code. So we will quickly format it. Okay. So the formatter is not there. So basically, we can see this created at completed first name, or the email address which was used to label, the ID, the image path uh, which was there, and created, updated all the look our thing, and this is basically the choice, the mountain. So all the annotation they are here. Basically, choice and image path, that is what we will be needing to perform to training his model. Now if you see, now we can go ahead and like run the training again. So if you see in here in the data pre-processing, we can open the logs, view logs. So basically, these are all the predicted images which are being copied from our S3 location, uh, this location, pred, this particular directory, to the particular folder. Yeah, these were the logs to the particular folder of the dataset, so that our model can be trained. Yeah. Now to run this pipeline again, since we have updated annotations, to run this pipeline again, you can go ahead, create execution. Now create another execution, give it some name, test3, any name, and click on the start button again. This will start another training process for it. So we already have multiple executions here, so I don't need any more. Yeah, so that's it for the project. Thanks for watching.